let's get started. So from this class onwards, we'll be dealing with the chapters one by one so that we can brush up the concepts and also we can do some revisions on the same. Okay, so we are starting with the first chapter, that is electric charges and fields, right? So this is the first chapter that we have discussed during the +2 classes initially in physics, right? And in this chapter we had discussed about the electrostatic concepts. Okay, so we have dealt with the charges at rest and electric field, etc. Okay, and we have also been introduced to a new concept, that is equipotential surface, its properties, etc, etc, etc. Okay, so I'm not going to the details of the concepts because we are already done with it. You have already been discussed about the concepts and the clear idea in detail when you have dealt with the chapter. Okay, so now here what I'm going to do is I'm going to discuss some of the questions that is related to this particular chapter. Okay, so you know that you are going to face an MCQ type of questionnaire pattern for this term 1 exam, right? And you have to get familiarized with the same. Okay, so for that I'm just trying to make you familiarize with what is MCQ type questions, how you have to deal with the assertion reason type questions, and what is exactly a case study and how you have to approach it. Fine. So let's get started. We'll discuss questions one by one. Initially, I have put a couple of MCQ, straight MCQ questions. So we'll discuss it first, and I want you guys to respond to it. There is a first question here. I'll go through the question. I want the answer by you in the chat box by naming A, B, C or D as the answer. Okay. So the first question here is, in comparison with the electrostatic force between two electrons. Okay, so you have two electrons, the electrostatic force between them. Okay, so if you are comparing it with the electrostatic force between two protons is, okay, so you have two protons now. So when you compare these two, okay, do you feel that the electrostatic force between two protons is greater comparing to that of electrons? Or if they are smaller, or the value of them is 0, or is that the same as that of the force between electrons? What do you feel? You can drop the answer in your chat box. There is Jerusha and Richa here as far as I can see. So now it's your turn. You can opt either A, B, C or D as an answer. Yes, what is there? Okay, Richa is telling me D. Nazrin is with the same answer again. Jerusha with D again, right? And I'm also with D itself. Yes, because if we have two electrons, right? And the same way they will be if there are two protons also. The force exerted between these two are the same because its magnitude is the same. Both of is having the same charge. Either both are negative or both are positive, and its magnitude is also the same. So anyhow, the behavior will remain the same. Okay. Now let's move on to the second question here. If electric flux through a closed surface is 0, it means that, okay, what do you mean by the statement if electric flux through a closed surface is 0? Okay, it is giving you an idea that the net charge inside the surface is 0. The electric field is necessarily 0 at all points on the surface. No charge exists inside the surface, or no charge exists outside the surface. What does this statement indicate? I think the options are clear for you. I have moved aside. Okay. Now start voting. No response? I have No answers, I guess. Why? What does it imply if the net flux through a closed surface is 0? The electric flux through a closed surface is 0. What does that indicate? Okay, I have option Richa and Jerusha with option A. Same option. Do anyone else have an option to say? What about others? Okay, anyways, with the response I've got, I'll tell you, yes, that is the correct option. Okay. Yes, when we say that electric flux through a closed surface is 0, we meant to see that the net charge inside the surface is 0. Okay. So, that's how we analyze the statement. Now, when distance between two charges is reduced to 1/2 of the original distance, that is R is made R by 2. The force between them will remain the same if one of the charges is made. Okay. So, what they have given is the force between the charges are remaining the same initially and after the change. Okay. So, the force has to remain constant, but initially the R value was, the distance was R, and now it has been made to 1/2 of R or half of R. Okay. So, what should be the change made to one of the charges? There will be two charges in action. The change can be made to one charge alone. Okay. So, what should be the change made to that particular charge, either Q1 or Q2, so that the force is remaining the same. Okay. So, what do you think would be the answer? Yes, Nasrin, Jerusha with option A. Richa with option B. Okay, I have 2 votes for option A and 1 vote for option B. Any more votes? No? Okay. May not be always, but this time the majority wins. Yes, it is option A. Why? Because we know that the force exerted between two charges is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. Right? And they have told that the R is made half. That means now the R is R by 2 square. Okay. So, R by 2 square means what? R square by 4. Right? So, if I am writing that, I can write it like 4 into 4 by R square. Right? Divided by R square by 4 can be written as into 4 by R square. Okay. So, here I have got a number 4 on the numerator. Okay. But I want the force to remain the same. I don't want it to be 4 times. So, what should I do? I should have a 4 in the denominator. Okay. So, for that to happen, I must make one of the charges to be Q by 4. Either Q1 by 4 or Q2 by 4. But for the change has to be made to one single charge. Okay. So, I am here taking Q1 just randomly. So, I have made Q1 by 4 here. What happens? This 4 get cancelled. So, even the R is being halved, the force is remaining the same. Right? So, I can say that, yes, the Q should be made Q by 4 so that the force is remaining the same even when R is made halved. Okay. So, I have to go with option A, 1/4. Clear? So whenever you're getting questions like this, you have to take the equation, substitute in that, and then check for the result. Okay? Now, 2-point charges, each of 20 microcoulomb, are placed 50 centimeter apart in air. What is the electric field intensity at the midpoint of the line joining the center of the 2-point charges? Okay, so when you get to see this type of questions, it's always better to give a diagrammatic representation of the question. Okay, so that will give you a clarity in the question. Okay, so let's check it out. You have two charges here with 20 microcoulomb each, and it is being separated at a distance of 50 centimeter. Okay, so you have 2-point charges, each of 20 microcoulomb, placed 50 centimeter apart in air. And you want to find the electric field intensity at the midpoint on the line joining the center of the point charges. So, from the center of this point charge to the center of this point charge, if you are joining a line, the midpoint of this, what would be the electric field intensity here? That is the question. Okay, so now I think you can answer this. Come on, shoot. Okay, one vote for C. Jirsha, Richa. Okay, so 3 votes for Z. Okay, cool. Well done. You are doing good. 3 of you are giving much contribution to the questions. So yes, the answer is correct that the value will be 0. Why? Because it is the midpoint of the line joining the two charges. So no matter what is the value of the charge and what is the distance between them, that the midpoint, the electric field intensity would be 0. So that was a tricky question. Now you have the next question here. A unit Coulomb charge is one which, when placed in air at a distance of 1 meter from an equal and similar charge, repel with a force of. Okay, so you have a unit Coulomb charge. What does that mean? It means it is a 1 Coulomb charge. Okay, and it is being placed in air at a distance of 1 meter from an equal and similar charge. So again a 1 Coulomb charge is there and the distance between them is 1 meter. And you had to consider the repulsion force existing between them. Obviously they are equal charges and that too similar charges. So if this is plus 1 Coulomb, then this is also plus 1, or if it is minus, then the other one is also minus, right? So there exists a force of repulsion between them, isn't it? So in that case, and if they are placed unit distance apart from the center, then what would be the force here? Come on, shoot. Okay, Nasrin, Jirsha, Richa, everyone with an option A. Yes, exactly, it will be A. Why? Because F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square. This is the equation. Here Q1 and Q2 both are plus 1, right? So making this 1 into 1. And you have the distance between them to be 1 meter. So again this is made 1 square. So the whole term had become 1 here now, right? So F is equal to 1 by 4 pi epsilon 0 here now. And we know that the value of 1 by 4 pi epsilon 0 is 9 into 10 raised to 9 Newton, making option A to be the answer. Okay. Now let's see the next question without further ado. An electric dipole of moment P is placed in the position of stable equilibrium in a uniform electric field E. The couple is required to rotate it through an angle theta. Okay, the initial position is. So you have an electric dipole and its moment value is given to be P, and it is being placed in the position of stable equilibrium in a uniform electric field. Okay, and we have given that the couple is required to rotate it through an angle theta. Okay, then the initial position would be, that's what you have to consider. What is the equation for that? What's your option? You have A, B, C, D, 4 options for the same. Go for it. It is about the dipole moment. It's a straight question, I guess. Any answers? Just remember the equations, the dipole moment, when there is a uniform field and you have placed a dipole, and if its momentum is P, and if the field is E, and it was rotating through an angle theta, then what is the value? No idea? Anyone? Should I support you? Okay, I have D as an answer from Nazreen. Okay, 1 vote for D. Anyone else? Any other option to you? Yes, only Nazreen has a opinion about this question, I guess. Is that so? Okay, then I must say, Nasrin, that's a very brilliant approach. Yes, it is the correct answer. It is PE sin theta. Okay, so these equations are already there in your concepts. So please have a brush up of it. Okay. Now, which of the following method is an indirect method of charging? You know that we can do charging by many different ways, and you have given 3 of them. And the last option is that none of these is considered to be an indirect method of charging. So you have to say whether none of them is indirect or one of them is indirect. You have to decide on it. Okay, there is charging by induction, there is charging by physical contact, there is charging by friction, and they have told none of this is an indirect method. And you want an indirect method of charging, not a direct method. So yeah, now tell me. Any idea, anyone? Okay, Jersha, Richa, Nasrin, all of them is option A. And yes, it is the correct answer. Charging by induction. Why it is termed to be an indirect method? Because there is no physical contact between the charged body and the uncharged body here. Right? If you are considering a physical contact, it's already given that there is a touch between these two objects. And if you have friction, again, we are rubbing one over the other. So there is also a physical contact there. So the indirect method left over is charging by induction. In this method, the charge from the charged body is being transferred to the uncharged body without touching each other. So that is considered to be the indirect method. Okay. Now, an electron and a proton are placed in the same uniform electric field. what will be the ratio of acceleration of electron to that of proton? Okay, so you have an electron and a proton, and they are being placed in the same uniform electric field, let that be E. Okay, and you have to find the ratio of acceleration of electron to that of proton. That is ratio of acceleration of electron to that of proton. Will that be equal to 1? Will that be 0? Will that be NP by E, or will that be ME by P? I mean MP. Now you have to choose. Yes, come on, go for the answer. Yes, I have option D by Jersha. What is the option given by Nasrin? I feel it like a question mark or something like that. We have asked 1. You want to ask that whether the option is 1. Okay. Is that so, Nasrin? Okay, I understood that. So, 1 vote for A and 1 vote for, okay, 1 vote for D. Okay, Nasrin, I got it. So, there was only 2 options given. Okay. So, which were the initial options given? There is A, okay. So, I would opt for option C. It will be MP by ME. Why? Because we know that if there is an electron and a proton, and if they are placed on the same uniform field, then the force exerted on them will be the same, because they are of equal magnitude, right? So, the magnitude of force will remain the same. But since they are having different mass, the acceleration on them will be different. And we know that from F is equal to ma, we have acceleration is inversely proportional to m, right? So, when you consider that if it is AE by AP, then it has to be MP by ME. Is that not so? So, hence I can go for option C here, that is MP by ME. Clear? Now, the next question is, if the sizes of charged bodies are very small as compared to the distance between them, then the charged bodies are called. If you have 2 charged bodies and if the size is small, very small comparing to the distance, okay, suppose that its size is this much and its size is this much and their distance between them is so big. On that note, what will you call these type of charges? That is the question. Okay. And you have it is to be test charge, bulk of charge, point of charge, none of these. It can be a bulk charge, point charge, test charge, or the option is not given here. What do you think is correct? C, option C with Jersha. You have voted twice, okay, and any other one, okay. I have one vote, rather two votes from the same person for option C. Only one option? Only one person to vote for this question? No one else? Okay, Nazrim, Aryananda with option A. Okay, I have two options with option A. Two votes for option A rather. So that's it. No one else is trying to vote. Okay. On that note, I'll support you. The answer is here the majority doesn't win. I'll go with option C here. That is point charge. Okay. Test charge means it is a charge that we make use of in order to analyze the field, analyze the force, etc. in the field. Right? So, suppose that there is a electric field because of a charge capital Q, and if you want to analyze the field, the potential, etc. in the field, then what will you do? You will take a small test charge and allow it to pass through that particular field. Right? So, test charge is an experimental charge that we make use of, as the word suggests. It is a test charge. Okay. So, no problem if the answer goes wrong. That's okay. So, the correct answer would be point charge. Okay. The distance between them is so large comparing to the size of it. Such a charge is termed to be point charge. Fine. Now, let's move on to the assertion reason type questions. Yes, now you have an idea about how the straight MCQs would be. Right? You may have any sort of question that can be a numerical, that can be a theory type, that can be a question which involves analysis of the concepts. There may be questions which is giving you a direct answer to the question. Right? There may be necessity for calculating and to get into the answer. Right? So these and all are there when you consider an MCQ. And when it comes to assertion reason type questions, it is more of an analysis and inference pattern of the concepts. Okay, so you must be very thorough, you must be very clear with the concepts. The clarity of your concept is giving you the correct answer. The more you clear with the concepts, the more is the chance for you to get these questions correctly. Okay, so let's see how much is your clarity in the concepts. Okay, so here's your first assertion. The assertion given is that in a cavity within a conductor, the electric field is 0. Okay, so they have given you a statement that if you are considering a conductor with a cavity within a conductor, then the electric field there will be 0. Okay, so that is the assertion they have made. And they have told you that the reason for that is charges in a conductor reside only at its surface. Okay, so they are telling that if you have a conductor, then inside that, this part, okay, there is no field. E is equal to 0. Okay, and for that they are giving the reason that the charges are on the surface. Okay, so do you agree with this? Okay, so what you have to analyze? You have to see whether the statement given in the assertion is correct, and you have to check whether the statement given in the reason is also correct, and you have to analyze whether the reason is giving you the correct explanation for the assertion. Okay, so at times maybe the assertion and reason are correct, but it may not be fitting into the correct explanation of the assertion. Okay, on that note you have to opt for B. If both of them are correct, then you can opt for A. Okay, and if the assertion, the statement is correct, but the reason given itself is an incorrect statement, on that note you can go for option C. Okay, and if both the statements are wrong, you don't have to check whether the explanation is correct or not. On that note, you can go for option D. And at times in your question paper, there may be, the option D may be like assertion is wrong and reason is correct. It can also happen, right? Maybe the assertion statement given is wrong and the recent statement is correct. It may not be the exact explanation or something, but the statement may be correct. Okay, so in that case, you can opt for option D. Okay, so whenever you have given an assertion reason, please go through the A, B, C, D options in it and check whether it is the same options as it is when you have practiced it. Okay, so here I have taken D to be both assertion and reason are incorrect for this particular thing. Okay, so now you have to tell me, in this case, I have told that the cavity within a conductor, the electric field is 0, and the reason for that is considered to be the charges in a conductor is residing only at its surface. That's what I am giving as a reason. Okay, now tell me whether it is option A, B, C or D. Just think over it. You have a conductor inside which the field is 0. Just first think whether that is possible. If yes, go for reason 2. If yes or not, go for reason 2. And then check the charges in the conductor is residing only at its surface. That is the second thing given. Is that a correct statement? If both of them are correct, then C and D are neglected there itself. There is a 50-50 now. Okay, so that's how you have to analyze the concept when you have an assertion reason. Check the first statement, then go for the reason statement, and if both are correct, then go whether it is the correct explanation or not. Likewise. Okay. So now tell me whether it is A, B, C or D. Come on, start the vote. So Nasrin, Aryananda, Jirsha, you are telling that the option is A, that both the assertion and reason are correct, and reason is the correct explanation of the assertion. Okay, I think I have 3 votes for this option then. Any other option? Anyone? Okay, so if you want to go with that particular option, then I don't mind. I'm also going with the same thing. Yes, I would say that it is option A. Okay, it is because the conductor is having charges only at its surface, and because of that, inside or within the conductor, the electric field is 0. Okay, so you got that concept now. Now moving on to the next question here. Coulomb force and gravitational force follow the same inverse square law. So what does this inverse square law indicate? It gives you an idea that the force, whether you have 2 forces here, whether it may be Coulomb force or gravitational force, inverse square law indicates that that force is inversely proportional to square of any quantity. Square of charge, square of distance, square of electric field, square of temperature, anything, I don't mind. Okay, if you have a quantity which is depending on, which is inversely depending on the square of another quantity, then we can say it obey inverse square law. Okay, so now you can check the assertion, the Coulomb force and the gravitational force. You are familiar with both of it. It follows the same inverse square law. That is the first statement given. And the reason given is that both laws are same in all aspects. Okay, so that is the reason given. Now you can go for vote. You know what does A, B, C and D indicate? So just say whether both of them are correct or not, or either of one is correct, etc., etc. Yes, I have option C from Jirsha, that assertion is correct but reason is incorrect. Okay, so I have 1 vote for C. Richa again with C. Okay, 2 votes. Let's see whether it goes with the majority. So that's it. Only Jersha and Richa want to reply. The others have no clue regarding the same. Okay, then I'll also go with them. Yes, it is option C. Why? The first statement, rather the assertion is what? It is Coulomb's force and gravitational force follow the same inverse square law. We can check it through the equation. What does the Coulomb's force give? One is F is equal to 1 by 4 pi epsilon 0 Q1 Q2 by R square, right? And you have gravitational force too. And what does that give you? Capital G into M1 M2 by R square or D square. So what does that indicate? Coulomb force is inversely proportional to square of distance. Gravitational force is also inversely proportional to square of distance, right? So these two are obeying inverse square law. And see to it that it need not be always distance, okay? For here, randomly or rather coincidentally, both of them are depending on the square of distance. But to obey inverse square law, it is not necessary that the denominator, the square of the denominator should be the distance itself. Not necessarily. Any quantity. The quantity on the left hand side should be inversely proportional to the square of any other quantity in the right hand side. That is it. Okay. And since it holds here, we can say the assertion is correct. Okay. This is fine. Now, both laws are same in all aspects and you are telling that the reason is incorrect by opting option C. Right? Why? It is because when you have these two laws, there is Coulomb force and gravitational force, okay, it has got many similarities, but one is in the electric field, other is in the mechanic field. The way of, or rather their areas are different, that's okay. But when you consider the aspects, in all aspects it is said, no. Why? Just consider one thing, that for Coulomb force, there is two forces possible. It can be either force of attraction or force of repulsion. But do gravitational force has this choice? No, never. Because gravitational force is purely attractive in nature. Right? So we can't say that both laws are same in all aspects. There comes a problem. Okay? So hence we can say that even though the assertion is correct, the reason is incorrect. The statement itself is incorrect. Okay, it is not necessary that it is not giving you correct explanation or something like that. First check whether the statement is true scientifically. Clear? Now let's discuss the next question here. The assertion is that Coulomb force is dominating force in the universe. Okay, again with Coulomb force here, and they are telling that it is the dominating force in the universe. Clear? And the reason given is that Coulomb force is weaker than the gravitational force. Okay. So, we have considered Coulomb force to be weaker and it is the dominating force. So, what is your option? A, B, C or D? Okay, I have coming C as the option, I guess. Richa, Jersha. Okay, Jersha is with option D now. Change the mind. Richa with option D. Okay, just started voting then. Jersha and Richa with option D. 2 votes. Others? Any idea? Okay, I'm also moving with Jersha and Richa. Yes, the option is D. That is, both assertion and reason are wrong. Why? Assertion says that Coulomb force is the dominating force in the universe. Is that so? No. But Gravitational force is the dominating force in the universe. In the universe as such. That is the only universal law. Right? Gravitational law or gravitational force is a universal force. Clear? And that is the dominating force. Now the reason given is that the reason is not the explanation of assertion for sure, because assertion itself is wrong. Now we just want to check whether the statement given in the reason is correct or not. Right? For that, let's see. It's given that Coulomb force is weaker than the gravitational force. Is that possible? No, because we have gravitational force to be the weakest of all. We have already told that gravitational force is the weakest force in nature. We have discussed it from 9th standard onwards. When you are introduced to gravitation, the concept of gravitation itself, then and there itself, it was mentioned that it is the weakest force. Then how can it be greater comparing to Coulomb force? Right? So on that note, I can say both assertion and reason are incorrect. Clear? Moving on to the next question now. Assertion. Range of Coulomb force is infinite. Reason given is Coulomb force acts between two charged particles. Now you tell me. The range of Coulomb force is infinite. And the reason to be Coulomb force acts between two charged particles. Tell me whether it is A, B, C or D. D with Jersha. Okay. Only one vote for D from Jersha. Nasrin with D again. No other vote? None of the others want to vote for this question? Where are the rest? Come on. Give it a shot. Okay. Then I would say here the majority doesn't win. I would go for option B. Why you felt that both of them are wrong? They are the correct statements. Range of Coulomb force is infinite, obviously. Because we can keep these two charges at any distance that you want. R can be as long as enough. R can tend to infinity. Right? So, Coulomb force has an infinite range. So, the assertion is correct. Now, you have to check the reason. Coulomb's force acts between two charged particles. Obviously, the force itself says that it is 1 by 4 pi epsilon 0 Q1 Q2 by R square. It is existing between two charged particles. Definitely. Why you felt that to be wrong at least? Okay, that is okay that you don't know whether the Coulomb force is infinite or not. But don't you know that they need two charged particles? You got confused? So, these two statements are correct, but it is not giving you the correct explanation. That is okay. So, because of that, I can say it is option B. Okay. Now, the assertion here is the surface densities of two spherical conductors of radii R1 and R2 are equal. Then, the electric field intensities near their surfaces are also equal. And the reason given is here, surface density is equal to charge by area. So, these are the two statements given, and you have to check whether they are true or false, or if one of them is true. Come on, go for it now. It's given the surface densities of two spherical conductors. Okay, you have two spherical conductors of radii R1 and R2. Okay, the electric field intensities near their surfaces are also equal. Okay. If the charge densities or if the surface densities of these two are equal, they are telling that the electric field intensity should also be equal. No matter the radius are different. That is the statements imply. Okay, you have two charged spherical conductors of different radii, but both of them are having same surface density. And they are saying that if so, the electric field intensity in both of them, near the surface of both of them, will be equal. No matter it has got different radius. That is the first statement says. Okay, I have an option B from Nasrin. Okay, 1 vote. 2 vote from Rucha. Jarsha, 1 more vote. So 3 votes for option B. And yes, that is the truth, because yes, if the two conductors is having same surface density, then the electric field intensity near the surface will be equal for both. Okay, so this statement is true, and the reason given is surface density is equal to charge by area. By definition and by equation, that is true again. You don't need any explanation for that, right? If it is charge by area, then it is surface density, right? Charge per length is linear charge density. Likewise, you know that already. There is lambda, sigma, etc. Okay, so surface density is nothing but charge by area. So that is also true, making it B, because it is not giving you the correct explanation, right? Charge by area, from this you are not getting that irrespective of radius, the field intensity will be equal. There is no statements regarding electric field intensity here. So the explanation is not correct, but both the statements as such are correct. Okay. Moving on to the next assertion again. The assertion given is electric field lines are discontinuous curves. Okay. And the reason given is that field lines overlap. Now it's your turn whether to say it is correct or not. You have electric field lines are discontinuous curves, and the reason given is that field lines overlap. Just check whether the electric field lines are discontinuous curves or not, and just analyze whether the field lines do overlap or not. And on that note, give an option. You have option D from Nasrin. Only one. Only Nasrin want to vote. No one else has the guts to face this question now. Come on, it's a simple question, simple statement. Okay, then Nasrin, I'm sorry, the answer is C. Even with Trisha, Richa, Jarsha, everyone is giving the same option D, but I would say sorry to you people because the answer is C. Because the assertion is correct. Electric field lines are discontinuous curves. Magnetic field lines are continuous curves, but electric field lines are discontinuous curves. They are not forming any continuity. For a magnet, okay, inside the magnet is from south to north, outside the magnet is from north to south. It is giving you a closed loop. There is a continuity. There is a continuous curve. That all is fine. But for electric field lines, there are discontinuous curves. Okay, so that statement is correct. Assertion is correct. But reason, you yourself know that no two field lines can intersect each other. They can't overlap. Right? So that is not a possible thing. So reason is incorrect, making it option C to be the answer. Okay. Moving on with next assertion again. A charge Q is lying at the center of the line joining two similar charges Q each. Okay, so there are two similar charges capital Q each, and at the center of the line joining these two charges, there is a charge Q present. The system will be in equilibrium if Q is equal to minus Q by 4. If its value is minus Q by 4, the system will be in equilibrium. That's what the assertion says. Okay. And the reason given is, for Q to be in equilibrium, the sum of the forces on it due to the other two charges must be 0. Okay. So it is saying that for Q to be equilibrium, the sum of the forces on it due to these two charges should be equal to 0. That is, if the force exerted by this charge is F small q and the force exerted by this charge is F capital Q, then Fq plus F capital Q should be equal to 0. Then capital Q will be in equilibrium. This is what the reason says. Okay. You have the next two options here. It's not like you have only A and B. You have C and D here just because of the space limit. So you just have to tell me what would be the answer. Option A. Okay. I have option A from Nasrin. 1 vote. No one else? Aryananda again with option A. Only 2? Okay, then I would say that the answer is correct. It is option A. And the sum of forces acting on it should be equal to 0 so that Q is in equilibrium. Right? Both the statements are correct and it is giving you the correct explanation too. That is why we have made capital Q to be equal to minus Q by 4. Right? So it is option A. Moving on to the next assertion here. Coulomb's law of force is applicable for point charges at rest. Reason, Coulomb's law is a central force. Okay. So they have given you two statements that Coulomb's law is a central force and Coulomb's law is a force that is applicable for point charges at rest. So now it's your turn to decide over. Does Coulomb's force is applicable for point charges at rest? Is Coulomb's law a central force? Jersha is with A for this question or for the former one? Nasrin is with C. 1 vote. Only Nasrin? I've observed that if it is a, okay, I have Aryananda with option B and Jersha with option A. Okay, 1 vote each for 3 options now. Anyone else with any other option? I have 1 vote each for A, B and C. Okay, Richa with B again. Okay. Fine. Then here I would say majority wins. Yes, it is option B. It is true that the Coulomb's force is applicable for point charges at rest, right? And Coulomb's law is a central force, like gravitational force. In the former questions, we have discussed that Coulomb's force and gravitational force are similar in all aspects. But that was wrong because it is not true for all aspects. But in certain cases, they are similar. Okay, just like gravitational force and Coulomb force, both have got infinite range. Okay, and both of them obey inverse square law. And both of them are central forces. Okay, so A and B, both of them are correct, but central force is not the reason for being used it for point charges at rest. So option B would be the perfect answer for this question. Okay. Now, moving on with the next assertion, that electric charge is quantized. Okay, and the reason is charging is because of transfer of an integral number of protons or electrons. There is integral number of, okay, integral number of protons or electrons. So that is why the charging is happening, because of the transfer of protons or electrons. And I have C from Nasrin already. What about the rest? Whenever there is a single vote, it's always from Nasrin, I guess. Yeah, there is Jarsha again with C. Aryananda again with C. Since 3 of them are opting C, then let me also opt for C. Yes, that is the correct option. We know that an electric charge is quantized, right? There is quantization of charge. Q is equal to plus or minus NE, right? But the reason given is that charging is because of the transfer of an integral number of protons or electrons. Obviously, because of the transfer of integral number of particles. But with the transfer of electrons, not with the transfer of protons. Okay, charging is caused by the transfer of electrons, integral number of electrons, not protons. So there is an option like either protons or electrons, their transfer can make it to charge. No. Okay, so the reason is incorrect, but assertion remaining to be a correct statement. So the option would be option C. Clear? So that's all for today. We shall discuss next questions in any other time. Okay, so let's see in the next class. Thank you all. Study well. Okay. Thank you.